Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at part 1 of the guided notes on volume of prisms. Let's take a look at this. Volume is the number of 1 by 1 cubes that can fit inside of a 3-dimensional shape. So kind of like area, except area is for 2-dimensional shapes. Volume is the amount of 3-dimensional space that you can fill inside that 3D shape, and it's officially measured in cubic units, actually 1 by 1 cubes. We can show that with a little 3 in the corner of whatever unit of measure we're talking about. So cubic inches with the inches with the little 3, cubic feet with the feet being cubed there, little power of 3. That's how we show cubic units for volume. All right, let's talk about how this guided notes is going to start, specifically talking about polygonal prisms. Now, our formula sheet will show you, I believe in the bottom right-hand corner, the polygonal prism. What does that really refer to? It refers to a prism where the bases are 2 polygons that are parallel and congruent to each other. Now, what do I mean by polygons? I'm talking about shapes with straight sides. Could be triangles, could be trapezoids, could be rectangles, could be pentagons, as you see here. With this one, we have the pentagon on the top and the pentagon that is exactly the same as it at the bottom. Notice they are parallel and congruent to each other. So that's an example of a pentagonal prism, but this is just generic drawing for any polygonal prism. The bases will be 2 parallel congruent polygons, either triangles, trapezoids, pentagons, rectangles, whatever. Now, for the volume of a polygonal prism, the formula is capital B times lowercase h. Now, capital B is the area of the 3D figure's base. We will use area formulas from our formula sheet to get the value of capital B. The variable that's called lowercase h, often called the height, is the line segment that goes between the 2 bases. Now, on this drawing on our formula sheet, it goes up and down. But depending where the bases are, it might not always go up and down. So here's some examples here. Remember, bases of a prism are always parallel and congruent to each other. So the triangular prism, sometimes the triangles will be at the top and at the bottom, like you see here, but other times they could be in the front and in the back. So every drawing is going to be a little bit different. You have to look for the triangles that are parallel and congruent to each other to be able to identify the bases. Then the height will be the line segment that goes between those 2 bases. Sometimes it's up and down if the triangles are at the top and the bottom. But if the triangles are in the front and the back, then the height will kind of go from front to back. Same thing is true with a trapezoidal prism. Notice there's going to be a trapezoid at the top and at the bottom, parallel and congruent to each other. Or you could have the trapezoids in the front and in the back, parallel and congruent to each other. So always look for the polygon that is parallel and congruent to each other, whether it's trapezoids or whether it is triangles. And then once again, the height will be the line segment that goes between those trapezoids. Same thing here, line segment that goes in between, that's what we call the h, the height. Now, before we go any further, since we're going to use area formulas to get capital B, I need you to make sure you understand the difference between capital B and lowercase b. Capital B is the area of the 3D figure's base. If the base is a triangle, then you want the area of the triangle. If the base is a trapezoid, then you want the area of the trapezoid. Lowercase b is an actual line segment called the base. Think about how triangles have a line segment called the base, which will intersect the height at a right angle. We talked about that in guided notes in the past. With trapezoids, there's 2 line segments called B1 and B2 that are parallel to each other, and they will also intersect the height at a right angle. So don't get capital B mixed up with lowercase b. They're very different. All right, so I have 2 examples already typed up for you. The first of which is finding the volume of a triangular prism, and then the second one is finding the volume of a trapezoidal prism. They both act the same way. You have to find the bases. They are the shapes parallel and congruent to each other. This example has them in the front and in the back. With the trapezoidal prism, I have them at the top and at the bottom. So every drawing is going to be different. You have to find the parallel congruent polygons to each other, whether they're trapezoids or whether they're triangles. All right, once you have identified the base, the volume formula, capital B, as I already mentioned, is the area of the base. So I recommend drawing an actual sketch of the base. That's the first thing I do for any triangular prism or any trapezoidal prism. Draw a picture of the base. So this triangle in the front and the back, I'm making a quick sketch of it. And since the area formula of a triangle, which I'm going to need to get capital B, is 1/2 times lowercase b times lowercase h, I need to label my sketch with the measurement for the lowercase b and the measurement for the lowercase h. So looking back at my original drawing, remember how the height, lowercase h, is normally a dashed line. So what is that? That would be the 7.8. So I go ahead and I label that on my drawing. And then for the line segment that the height touches at a right angle, I can see here that is the 12.25. So I go ahead and label that. I don't need the 9 feet. I don't need the 11-foot length. I would need that if I was getting perimeter. But for area, I just need the lowercase b and the lowercase h. All right, so formula, substitute, solve. We substitute those numbers in for the base and the height, get our area. That area will become the capital B. And you can see that right here. So how do I get the h? Go back to the original drawing. Find the line segment that goes between your triangles. That would be the 15 feet. That is my height. Forgive me, I didn't even have to scroll down. I could have just looked at the drawing right here. That is my height. So whenever you have found your parallel and congruent polygons, the line segment that goes in between, that will always be your lowercase h for capital B times h. All right, so substitute that in, get your answer, label it with cubic, whatever you're talking about. In this case is cubic feet, and you are done. Here's the other example that I have on the right side of your guided notes on the first page for the trapezoidal prism. Again, we have a trapezoid in the top, we have a trapezoid in the bottom. They are parallel and congruent to each other. That's how I know they are the bases. I'm going to draw a quick sketch of that trapezoid, and I'm going to label it with the measurements I need from its area formula. So from the formula sheet, I write down the area formula so that way I can get the area of the base. I need an h, and I need a B1 and a B2. Remember, the B1 and the B2 are the parallel sides. So that's the 21, and that's, what's this measurement here? Oh, it's the same as it down here. So 11 and 21, they are my B1 and my B2. But what about the height that intersects those bases at a right angle? Oh, I can see from this drawing, this one was actually pretty easy to see. The 6.5 inches, that's that dashed line. That is the height. So formula, substitute, solve. Use my calculator. If you know where the parentheses keys are on your calculator, then you can do this all in one shot. You get an area of 104. Where does that go? The area becomes the value of capital B. And then to get the height, you need to find the line segment that goes between those trapezoids. Well, that would be the 13 inches. So I go ahead and substitute that in, and boom, multiply my calculator. I get 1,352. This was inches for all my measurements, so the volume is going to be in cubic inches. So make sure you have the little 3 for cubic inches. All right, flip the page. At the top of the next side, what do you do when the area of the base is given? Well, that's going to make your life so much easier. Here you can see we have a hexagon at the top and a hexagon at the bottom. So those hexagons are the bases. To get the area of the base, oh look, it's already given to me, capital A for area. So I substitute that in for the base, and then I obviously find my height. That's the line segment that goes between my hexagons. So that's the 15. Boom, formula, substitute, solve. And this is a lot quicker than what we had on the previous page where we had to find the area This one was already given to me, so yay, easy math. Boom, done. Now, there are two prisms where you are not gonna want to use the formula of volume equals the area of the base times the height. And those two prisms are the rectangular prism and the cube. The rectangular prism has the most basic volume formula. You probably learned this back in elementary school. The length times the width times the height. And the beauty of this is it doesn't even matter which measurement you call length, width, and height. Just pick a number for the L, pick a number for the W, pick a number for the H. It doesn't matter if it's the same as your neighbor. As long as you're using all three measurements, you will be fine for the formula substitute solve to get the volume of the rectangular prism. And for the cube, it's even easier. A cube is just a rectangular prism where all measurements are always the same. So we say the length of a side, generic S. That length goes in for S. You take it to the third power, or you multiply it times itself and times itself again, and you're done. So that one's really simple. So for those two prisms, the rectangular prism and the cube, do not use the V equals capital B times H. Instead, use length times width times height for the rectangular prism and use S to the third power for the cube. All right. Now that I talked you through two examples from the first page, and I talked to you about what do you do when the area is already given to you for the base, and what do you do for the rectangular prism and the cube, I think you should be good to go to do the next problems on your own. Number 1, number 2, number 3, number 4. And if you don't feel like you're ready, I'm telling you, you can go back, look at how I explained number 1, look at how I explained number 2 on the first page. Actually, I don't even think I numbered them. Forgive me. They weren't even numbered. Draw the picture of the base, whether it's a triangle or the trapezoid. Find the measurement that goes in between for the H, and everything else will fall into place. You will be able to do these on your own. So hit pause in the video, do 1, 2, 3, and 4 on your own, and then hit play when you're ready to see how you did. All right, did you already do number 1, 2, 3, and 4 on your own? If you need a jump start for number 1, let me give you a jump start. This is definitely a triangular prism. I know that because there's a triangle in the front and a triangle in the back, kind of at the bottom and top, that are parallel and congruent to each other. So I'm going to quickly draw a sketch of that triangle. It's actually a right triangle, little right angle in the corner. So what are the measurements that I need? Well, for the volume, capital B times H, but capital B is the area of whatever my base is. My base is a triangle. Find its area formula. Boom. What's the base and the height? Well, they are the measurements that meet at a right angle. You can see here, 15 meters is this length and 8 meters is this length. They meet at the right angle. So draw those or label those measurements, on your sketch for the drawing of the base. And then formula substitute solve. You should be able to get the area and then eventually get the volume. So if you needed a jump start, you didn't know how to start number 1, well, now you know how to start it. Hit pause if you haven't already finished this on your own, and continue keeping it on pause as you do 2, 3, and 4 on your own if you haven't done them already. All right. I hope you already did 1, 2, 3, and 4 on your own, because I'm now going to finish showing all the rest of the work. So formula, substitute, solve. Here's your substitution. There's your area of the triangle. Now you can put that area in for capital V in the volume formula times the height. Now, what was the height of the prism? It's the line segment that goes between the triangle. So that line segment is the 16.5. Boom. Substitute it in. Multiply it. You're going to get 990. Since everything was in meters and this is volume, it's cubic meters. Make sure you have the little 3 in the corner. All right, what about number 2? This is a trapezoidal prism. We know that because there's a trapezoid in the front. That is parallel and congruent to the trapezoid in the back. So first things first, let's make sure that we are going to draw a sketch of our trapezoid and label it with the measurements we need to get its area. From the formula sheet, here's your area formula of a trapezoid. It has height, which is normally a dashed line, and it has B1 and B2, which are parallel to each other. All right, so that height, as you can see here from the original drawing, is this dashed line. Where do they give us that measurement? It's not the 29.65, that's this diagonal. Oh, here it is. That's your height. So I'm going to label that on my drawing, and then I need the base 1 and the base 2. They would be the two line segments parallel to each other on that trapezoid. So that's going to be these two guys. Well, the bottom one's definitely 53. What's the top one? Oh, it's this guy, because that line segment there is the same as the one here. So that's 27. All right, so let's go ahead and label those 27 and 53. Now I have the measurements I need to substitute them in to my formula. So formula, substitute, solve. Use your calculator. Boom, 1,180 is your area. Now I can put that in to the volume formula. That will replace my capital B. All right, let's go ahead and put that in. And times the height. What's the line segment that goes between my trapezoids on the original drawing? That would be this guy. That's the line segment that goes between the trapezoid in the front and the trapezoid in the back. So that is your height. Formula, substitute, solve. 70,800 cubic feet, because volume is always in cubic units. All right, that brings us to number 3. And this one is kind of like the one at the top left-hand corner of this page, where the area of the base is already given to you. Hallelujah. That's going to make this so easy. Formula, substitute, solve. Replace capital B with the area of that pentagon. The height is the line segment that goes between the pentagon in the front and the one that we can't even see in the back. So that is your height. Multiply, make it cubic yards. Yes, the area is in square yards, as area always would be, but the volume's cubic yards. There you go. By the way, if I went over any of those problems too quick, hopefully you realize you're able to hit pause, you're able to hit rewind, do what you got to do to make this video work for you as you're checking your work. All right, problem number 4. If the prism below is filled 85% full with water, how much water will it hold? This is a rectangular prism. So right away, do not use V equals capital B times H. Yes, you could make it work. You could find the area of the rectangle, multiply it times the other measurement that you haven't used yet for the H. Yes, you could, but I'm telling you, length times width times height is the absolute easiest way to get the volume of a rectangular prism. And it doesn't matter which number you call the L, which number you call the W, which number you call the H. You could flip-flop these because of the commutative property, and it would not matter. So multiply those numbers together. You're going to get 607.5 cubic feet. But do not circle that. We have not answered the question. The question is, if it's filled 85% full, then how much water can it hold? So we need to take this times 85%. Now, what does 85% really mean? It means 85 hundredths, because the percent symbol means out of 100. So make this 85 hundredths, 0.85. Take that times your volume, and that will give us how much water this could hold if it's 85% full. Boom, that's going to give you 516.375. I did not round it. You should not round it either, because there's no reason to round it. The directions didn't say to round. It wasn't some kind of ugly decimal that you would need to round. No big deal. 516.375 or 516 3/8 if you had a mixed number cubic feet of water. That's what this could hold if it's 85% full. All right, one more problem to go for part 1 of the video. We'll do the rest of this in a separate video, but number 5 I'm going to include in this one. A mini house. How are we going to do this? I want you to notice there is a triangular prism at the top. Then there's a really big, almost cube, but the 3 measurements are different, so we're going to call it a rectangular prism at the bottom. You're going to want to separate this into 2 pieces. The work for the triangular prism and the separate work for the rectangular prism. And then like you would for a composite 2-dimensional shape, you're going to do the same thing for a composite 3-dimensional shape, where once you get the volume of the triangular prism and the volume of the rectangular prism, you will add those two volumes together to get the volume of the entire mini house. All right, so that's what you're going to do. Hit pause in the video, do that on your own, and then hit play when you're ready to see how you did. All right, triangular prism at the top. Let's draw a quick sketch of that triangle before we can find the value of capital B. What is the height? What is the base? Well, the height is the dashed line. Let's find it. There it is, 3 feet. So let's go ahead and label that. And what does it touch at a right angle? It touches this line segment. So what is that? Oh, that's going to be the same as this guy down here. So that is the 10 feet. Now I can do formula substitute solve using the area formula of a triangle. That's what you use to get capital B, area formula, whatever the shape is. Put those numbers in, and you get an area of 15 square feet. Now I can put that into the volume formula. V equals capital B times H. The capital B is the 15. Oh, what's the H? It's the line segment that goes between the triangles. So here's the triangle in the front, or on the right side. Here's the triangle in the back left. The line segment that goes in between, what is that measurement? Oh, that's this guy, the 12. So that is my H. Whatever line segment goes between your bases, goes between your triangles, that is your H. So substitute it in, multiply times 15, you get a volume of 180, but that's just for the triangular prism. What about the rectangular prism? What are the 3 measurements of the rectangular prism, of the box? It's the 12, it's the 10, and it's the 8. Those 3 measurements are the length, width, and height in any order that you want to put them in. Boom, 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 boom. Multiply it, and you get 960. Now, let's take the volume of the triangular prism, add it to the volume of the rectangular prism, and you get 1,140 cubic feet. All right, the last part of the guided notes with inverse operations, I'm going to make that a separate video. So thank you for watching part 1. We'll go ahead and see you next time.